Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will learn about matrix with the last sub-capture, which is solving equation system with Miss Rara. Without further ado, so what is from solving equation system matrix? Solution of a system of linear equation by matrix inversion method. Actually, we already learned how to solve a system of a linear, right, from the previous meeting. But in here, we propose to solve with the matrix inversion method. So the first, we consider the following two linear equation into unknown x and y. Okay, let's say we have ex plus by equal e and cx plus dy equal f. And then this equation can be written as ex equal b, the first equation. Okay, we already know if the a b c d is from the matrix A, and then x equal from the variable x and y, and then the b is from ef. So from here we now pre-multiply equation the first by A inverse, and then the both side from the first we multiply the both of them with the A inverse, and then they will be get A inverse times ex equal A inverse b, or we can make it A inverse times A times x equal A inverse times b. We already know from the previous meeting A inverse times A is actually equal with the identity times x equal A inverse times b. So when you want to multiply identity with the x, that the value will be the x, so x is also equal A inverse times b. Okay, so thus the solution of system of equation is obtained from x equal A inverse b. So when we have the variable x after A, so the result will be x equal A inverse times b. How about if they are reversed? This equation can be written as xa equal b, the second equation. Okay, we know that the a, the x, and the b is the same with the previous. Now we multiply again from the second, which is xa. When you want to multiply the a and the 2 with the a inverse, you need to put that the a inverse after the a. So from in here we have the a in the back of the x, so you need to put the a inverse in the back from the a. So it's the same with the previous one. So we simplify this one. So this one is equal with the x time identity equal b times a inverse. It's also equal with the x equal b times a inverse. Thus the solution of the system equation is obtained from x equal b times a power minus 1. So what's the difference about the first equation and then with the second equation? The difference is if the first equation they have ex equal b, that's the meaning they put the a in the front of the x, which is when you want to find the variable, when you want to find the x, you need to put that a inverse in the front of the b. How about the second? From the second, when you find the equation xa equal b, when you want to put when you want to find the x, you want to put the a inverse in the after the b. So you can see from here, this one is x equal a inverse b. This one is from they have a in the front of x. So you put the inverse in the front of the b too. In here, they put a in the back after x for the second equation. That's the meaning you need to put that inverse in after b. Okay, so you get it without further ado. So let's jump to the example. Using matrix, solve the system of equation 3x plus y equal 5, x plus 2y equal 3. Okay, everyone. So from here, we have the matrix A. Matrix A equal with the, yes, 3, 1, 1, 2. And then we have the matrix X is X, Y. And then we have matrix B. It's equal with the 5, 3. You need to solve the system. Is that the meaning? You want to find the X and Y, right? So from here, we can see from the position is AX equal B. Like I said before, when you find the A in the front of the X, there will be have the formula X equal A inverse times B. How about XA equal B? Because they have A after X, so the result will be have B times A inverse. Okay, you already know how to do different about this, how to use that formula, because they are from the first, we just continue, right? Okay, we just continue them. Okay, wait, there is something. Okay, so we can continue them to find what the X. Okay, from here, they have the formula like this, so we can write X equal with the matrix A, but they have inverse symbol. You can write the inverse symbol times with the 5, 3, right? So you need to first inverse, you need to do their inverse first. Inverse is the formula 1 over AD minus BC times, you need to change their position, and then adding minus times with the 5, 3, everyone. So from here, you need to substitute what the AD 3 times 2 minus 1 times 1, 2 minus 1 minus 1, 3 times with the 5, 3. Because they have scalar in the front of this, so you need to simplify them first. 3 times 2, 6 minus 1 is 5, right? So 1 over 5 times with the 2 minus 1 minus 1, 3 times with the 5, 3. Okay, so from here, you need to solve this one. Wait a minute. You need to solve this one to be 2 over 5 minus 1 over 5 minus 1 over 5, 3 over 5. You need to multiply. Remember, before you multiply them, you need to find their dimension. This dimension is 2 by 2, and in this dimension is 2 by 1, right? So this is the same, and with the P is the same. So this result will be have 2 by 1, all right? 2 rows and 1 column. You need to times between row and column. 2 over 5 times 5, 2 over 5 times 5, minus 3 times 1 over 5, and then minus 1 over 5 times 5, minus 1 over 5 times 5, plus 3 times 3 over 5. Okay, that's the bracket is not enough. So this one is 2 minus 3 over 5. And then this one is minus 1 plus 9 over 5. So what's the result? 10 minus 3 is 7 over 5. And then 4 over 5, everyone. So we get the value for the X is equal 7 over 5. And then Y is 4 over 5. If they're asking about, the answer will be like this or will be like this. Okay, I hope you understand. So let's jump to another example. Okay, they're asking, they already give us the matrix form from here. So you just need to remember because the matrix in the front of the variable X, so the result will be X equal A inverse times B. So what the A? This is A inverse. This is A, this is B. It's correct. So the X is 2, 5 minus 1 minus 3 power minus 1 times with the B. Yes, 1 minus 3, 2 and 4. Okay, because they're there is inverse, you need to solve them first. So minus 6 minus 5 times, you need to change their position, minus 3, 2 minus 5, and then the 1. And then this one is 1 minus 3, 2, and 4. And then you need to simplify their matrix. Minus 6, okay, this is minus 1, minus 3, minus 5, 1 and 2, and then 1, 2, minus 3, 4. And then you just, because this is a scalar matrix, you can simplify 3, 5, minus 1, and then 2, and then 1, 2, minus 3, and 4, because they have the same dimension. So the result will be, yes, correct, they will be have the value, they will be have the same dimension. So this one is row times column, 3 minus 15 minus 12, 6 times 6 plus 20, 24. Okay, minus 1, minus 6 minus 7, minus 2 plus x is 6. Okay, so this is the value for the x. So how about another example? So let's see another example. Okay, you can see from another example, they give us the form of the matrix already. They put the x after, they put the matrix after the x. So that's the meaning, this is A, this is B. So this the meaning, the formula is x equal B times A inverse, everyone. So from here, you need to simplify them to be 1, 4, 2, 2, times the inverse 1301 power minus 1. So the x equal 1422 times 1 over, so you need to simplify them, 1 over 1 times 1 minus 3 times 0. And then you need to change their position because they are the same value. 1 and 1 doesn't matter. And then minus 3 and then 0 because 0 doesn't have minus. So the x is equal with the 1, 4, 2, 2 times, because this value is 1. So you don't need to write them. So let me change the color. So this one is 1 minus 3, 0, 1, right? So you just need to simplify because they are, you just need to multiply, because they have the same dimension, so it doesn't matter. So you can just still continue them to be 1 times 1, 1, plus 0, 1, 1 minus 3, plus 4, 1, 2, 0, 2, minus 6, plus 2, minus 4. So they have the value of the variable x, 1, 1, 2, minus 4. So guys, I hope you understand from using matrix. Now we will talking about another way, okay? Okay, everyone, now we are using another rule. We are using Cramer's rule method. It's a little bit different with the matrix before, but in here you will also a lot of using determinant. Determinants 2 by 2, 3 by 3. Okay, so when we have the matrix with when we have the equation with just two variable, or you can they have sorry, or they have using three variables, x, y, and z. So from here we can find the Cramer's rule with the Cramer's rule method to find the if they have the equation system with the three variable. Okay, you can see from here, let D be determinant of the coefficient matrix of the above system, and let dx be determinant form by replacing the x column value with the answer column value, and dx and dz also. Okay, so this is the formula. So x equal dx over d, and y equal dy over d, and z over dz over d. Maybe you will still confuse what is dx, what is dy, what is dz. So without further ado, so let's jump to the example. Everyone, I will explain more about Cramer's rule. Okay, we already know if they give us about Kramer rules is asking, they're talking about x equal dx over d, and then y equal dy over d, and then the z equal with dz over d. Maybe you are still confused about this one, right? Okay, I can give you recommendation for using the Kramer's rule method. It just for the if they have more than two variable is for me, but it depend again from the question, what they ask, what they want to method you use, or anything they want. Okay, so from here, let us like, we have the equation, right? So ex plus by plus cz, and then a1 b1 c1, a2x plus b2y plus c2z, and then a3x plus b2. Okay, this one is b3y plus c3z, everyone. So this one is the value d1, d2, and then equal d3. I give more recommendation for this for the three variable. Okay. So for this, they're asking us x equal dx over d. What is the d? D is the determinant of the matrix. Okay, what they talking about matrix? Their matrix is A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is the D. Okay, how about dx? How about another, miss? Okay, for dx, dx that the meaning they are talking from the x column. This is x column, y column, z column, everyone. So from here, they give us the previous meaning about dx. Okay, what the dx? Okay, they give us already the determinant form by replacing a column with answer column value. Okay, remember when you want to using variable x, that the meaning you need to replace the x column value with the answer column value. Okay, we are back to the previous dx. The example about the x column value you need to replace with the answer column value. So dx to be d1, d2, d3. How about the second and the third column is still the same, everyone? Okay. How about dy? Dy is the same meaning. You need to replace the column y with the answer column value. So this one is equal A1, A2, A3, B, sorry, not B, but D. It's not B, but D. D1, D2, D3, and then the C is still the same, C1, C2, and the C3. How about DZ? DZ is still same meaning with the previous. So this one it's equal with the A1, A2, A3, B1, B2, B3. Remember, because they're asking about the Z column, you need to replace with the answer column value. So D1, D2, D3. Okay, everyone. So you just need to divide it before. The value of this one, you need to remember again how to solve the determinant from the matrix 3 by 3. You can using the rule of Sarus, or you can using the Laplace method. But from here, sometimes I will more recommended by Laplace, or sometimes I can give you for more to Sarus, but it's depend on you what you like more. Okay, so now let's jump to example. Solve the following system of equation using Kramer's rule. Okay, remember for Kramer's rule, they are using, because they just have two variables, so we can using x equal dx over d and then y equal dy over d. Remember that you need to find the d first. The d is that the meaning they're the determinants, correct? So determinant from the matrix 2, -1, -1, and 3. Determinant of this one is 2 times 3 minus 1 times -1, right? So this value is 6 minus 1. So this value is 5. Okay, you need to find the dx. What's the dx? Remember, when you want to using the dx, this is the value, this is the column of x. You need to replace them with the answer value, answer column value. So you can write, let me change the color to make it different. 3, 1, and then with the -1 and 3. Okay, so this result is to be 3 times 3 minus 1 times 1, it's equal with the 9, minus positive 1, it's equal 10, and then dy. Okay, you need to replace the y column with the answer column value. So we can write 2 minus 1, and then let me change the color to be 3 and then 1. Okay, so this result is to be 2 times 1 minus 3 times -1. So the result is 2 plus 3. So this result is 5, right? So you just to continue to find x equal dx over d. So what's the dx? Dx, the value is the 10 over, what's the d is 5. So the result is 2. And y equal dy over d. dy is the value is 5 over the d is 5. So 1. So we get the x equal 2 and then y equal 1. Okay, do you get it, everyone? So let's talk about another example, which is they have 3 variable. Okay. From here, if you're a little bit confused, you can write their matrix first. Matrix A equal with the 1, -1, and 3, and then 1, 2, -2, and then 3, -1, and 5. Okay, remember, because they have 3 variable, you can to find x equal with the x over d, and then y equal dy over d, and then the last is z equal dz over d. Okay, so from here, you need to find their determinant first. D is equal with. Okay, because today I will using the Laplace. Okay, the Laplace is I want to use the first row is the 1 times with the matrix with the 2 -2 -1 5, because I using the first row, so this is minus times -1 with the 1 -2 3 5, and then I want to using the 3 plus 3 times with the determinant of 1 2 3 -1. So from here, the value is, because 1 is 1 positive, doesn't matter, 10 minus 2 plus 5 plus 6 plus 3 minus 1 minus 6. So the value is 8 plus 11 minus 7 minus 21. So it's equal with 19, 20, 21, minus 2. I mean, everyone, sorry. Okay, everyone. So from here, we want to replace the first x column, this one with the first row, first column, I mean, with the row, because we are taking x. So this one is 4, and then 10, and then 14. Okay, after that, -1 to -1, -1 to -1. Let me smallest this one first. Okay, and then 3 minus 2 5. 3 minus 2 5, everyone. So from here, I will, like I said before, I want to using the Laplace method. So this one is 4 times with the 2 minus 2, 2 minus 2 minus 1, 5, and then minus 1 with the this one, 10, 2, 14 minus 1, and then plus 3 with the determinant of, okay, there is a wrong. Wait a minute, there is something wrong. Okay, guys, sorry, there is wrong in here. This one is makes me feel it's not right. Okay, let me continue. Minus 1 with the matrix is 10 minus 2, 14, 5. Okay, right in here. And then the last is 3 with the 10, 2, 14, minus 1. So from here, you can continue to be 4, 10 minus 2, 10 minus 2, positive 50 plus 28 plus 3 minus 10 minus 20x. So this result, it should be 4 times x plus 70x plus 3 minus 30x. Okay, this value is bigger. 28 plus 70x minus 4, 9, okay, 11. So 70x, 6, 7, 9, 10, minus 114. So this result is minus x, right? So from here, you need to find the dx, the dy, I mean. So the dy is to be, what's the first? Like, let me see there first. What the 113? Okay, 113, and then you need to change the y column with the result value 4, 10, 14, and then 3 minus 2, 5. Okay, you can see the difference between there. Okay, so from here, let me times with the 1 times with 10 minus 2, 14, 5, and then minus 4 with the 1 minus 2, 3, 5 with the 3 with the 1, 10, 3, 14. So let me adding some. Okay, now we continue. The value for this one is, okay, there is something in here. Let me continue to be 50 plus 20x minus 4 times with 5 plus 6 plus 3 times 14 minus 30. So 70x minus 4 times 11 plus 3 minus 16. So 70x minus 44. Okay, this one is time minus 40x. Okay, 40x, 70x, 30 minus 44. So this result is minus 14. Okay, now we continue this one with the same rule. 1 times 2, 10, 114. And then minus 1 times with the 1, 10, 3, 14. And then plus 4 with the determinant of 1, 2, 3, 1. And then this one to be 20x minus 10 plus 14 minus 30 plus 4. 1 minus 6 is minus 5. This one is 18 minus 16 minus 20. 20x minus 20 is 8. 8 minus 16 is minus x. So we have dz. We have, okay, let me write dz is equal minus x. And then what is dy? What is dx? And then what is the d? So we need to solve them first. Okay. Okay, dy is minus 14. Dy is minus 14, and then dx, what's the dx? Dx minus x minus 2. Minus x and then minus 2, everyone. So to find the x equal with the dx of a d, dx is minus x over minus 2. The result is 4. Y equal with dy of a d. dy is minus 14 over minus 2. It's equal 7. And then y equal dz over d is equal with the minus x over minus 2. So this result is 4. So you can write x 4, y equals 7, and then z, sorry, this is wrong. This is not y, but this one, it will be with the z. Okay, so we get the z is 4. So guys, this is the last our lesson about matrix. So now let's jump to the ends. Everyone, thank you so much for today. I hope you understand what I'm explaining. Please exercise more about Cramer's rule, about the determinant, about the inverse, about anything in from matrix. I hope you do your task. I hope you understand what I'm explaining. And then if you doesn't understand what I'm explaining, please let me know in my YouTube comment below. And then see you on the next capture. Assalamualaikum warahmatullahi wabarakatuh.